Good evening, everyone. I am Dr. G. Seshadri, working as a professor in Institute of Aeronautical Engineering. Today I want to discuss about Doubly Fed Induction Generator in AC Machines course. So, in previous class we have discussed about Doubly Fed Induction Generator and various performance characteristics of induction motor as well as induction generator. So previous class we have discussed more about induction generators. In that, singly fed and doubly fed induction generators are there. So now today we want to discuss about doubly fed induction generator. So what is doubly fed induction generator? So DFIG. So it is a type of electrical generator, so which is commonly used in wind turbines. So it allows the energy, mechanical energy, to be extracted efficiently from the wind in the form of wide range of wind speeds. So unlike in conventional generators, so these are also converts mechanical energy into electrical energy and has both stator, stationary part, and rotor, rotating part. Both are connected to the electrical sources. So here in this doubly fed induction generator, so it making a doubly fed system. So what is meant by doubly fed? So DFIG. So here for both the stator and rotor, we are giving the AC supply here. So unlike in alternators, so we are giving a three-phase AC supply to the stator winding and DC supply to the rotor winding. Here DC supply to the rotor winding is used to produce the magnetic flux or magnetic field. So in this, it is somewhat different to the conventional conventional generator. So here DFIG, we will see the construction and working principle. So it has main components, two main components. So those are stator and rotor. So stator here, which is directly connected to the grid, and it is responsible for the generating the output power. The stator windings here produces a RMF here, a rotating magnetic field produces, stator winding produces a rotating magnetic field here with a synchronous speed and with the constant velocity 1.5 times the maximum flux. So here the stator winding produces a rotating magnetic field. This rotating magnetic field causes the voltage or EMF induced in the rotor according to mutual induction principle. Nothing but it is also a rotating transformer, but here it is stator and rotor acting as primary and secondary. But here the main difference is we are giving a three-phase AC supply to the stator winding and also to the rotor winding. So in the stator winding, rotating magnetic field is produced, and rotor winding, the magnetic flux is produced. Magnetic flux is produced. So here wound type rotor, slip ring or wound type rotor is connected to the grid through a back-to-back converter. Here for this purpose, power electronic devices are used here. Power electronic devices are used. The rotor windings carry currents which produces the magnetic field. and this field interacts with the stator field to generate the mechanical torque. So with the interaction of both the stator winding and the stator winding field and the magnetic field causes the mechanical torque production. And the main, again, two parts in addition to the rotor and stator. Additionally, we have converters and brushes and slip ring. So here converters. So these are all used in rotor side only, that is secondary side only. Primary, it takes only 3-phase AC supply and to the stator. And in secondary, it has rotor. So your rotor side converters are used, or rotor side converters are used here. And also it is connected to the grid. So grid side converters are also used. There is also converter. There are two converters, rotor side converters and grid side converters are used in secondary side. And these two are used to regulate the rotor currents, so that here there is a possibility of stable voltage and frequency production. So voltage induced, which is a constant or stable voltage, is induced. And the whole frequency also here, a stable frequency is produced. So the rotor side converter controls here both the purpose of rotor side converter is to control both the active power and reactive power. So whereas the grid side converter sees that whether the DC link voltage is stable or not. So it manages the grid side converter manages the DC link voltage stability. Next, so purpose of slip rings and brushes. So these slip rings and brushes are used connection between the rotor winding and external converter system to facilitate the connection between rotor windings and external converter system. Although they require some maintenance, slip rings and brushes requires maintenance, and by designing in modern way, there is a chance to reduce the wear and chance to extend the life of the induction generator. So modern designs aims to reduce wear and extend its operational life. So operating modes, different modes are there. It depends upon the rotor speed. There are different modes that DFIG can operate. First, subsynchronous mode. Subsynchronous means, sub means here lower than the, less than the synchronous speed. Subsynchronous speed means less than the synchronous speed. So when the rotor speed is lower than the synchronous speed, then the converter supplies power to the rotor. And the direction of power flow from grid to rotor. Power flow grid to rotor, and it aids or helps the controlling the output power. It is subsynchronous mode. So subsynchronous mode is nothing but rotor speed is lower than the, if the rotor speed is lower than the synchronous speed, and the converter supplies the power to the grid, to the rotor, and this is from grid to the rotor. It helps in controlling the output power. Next, supersynchronous mode. Supersynchronous means when the rotor speed is greater than the, somewhat higher than the synchronous speed, it is called supersynchronous speed. And when the rotor speed is more than synchronous speed, the excess power from the rotor is fed back to the grid. Excess power fed back to the grid. So it is in the case of supersynchronous speed. So because of this, getting back power to the grid helps during, that is beneficial during wind speed is high. Here we can observe the DFIG operation in with the help of wind turbine. So here wind turbine we can observe here, and from, so here during windy season or when the wind is available, the rotor starts rotating, but the speed of the rotor is very low. So by using a gearbox, we can increase the speed. So here brake available and rotor bearings available, and pitch drive, which is the mechanism of wind power plant. So it is given to the DFIG as input. Here from DFIG stator, it will given to the grid from generator side by using power electronic converters. So here it converts AC to DC and given to the grid side, and again with the help of transformers it is given to the transmission line, and also from rotor side it is connected back to the grid. When the speed of the rotor is more than synchronous speed, the power is given back to the grid from the grid. So control strategy. Here in this DFIG, vector control methods used to regulate the active and reactive powers here. So by using rotor side converter, it is possible. The main control loops include here power control, voltage control, and maximum power point tracking, which is nothing but MPPT technique. So here power control, the power is controlled. Here the power means active and reactive power. The output power is controlled here. So by maintaining the desired power levels, increases the grid stability and efficiency, and efficient during utilization and efficient energy utilization, and voltage and frequency control. So maintain stable voltage and stable frequency by adjusting the parameters. Means we can, by adjusting the speed also we can adjust the frequency. Since ns equal to 120 f by p, by changing the number of poles and by changing the frequency, we can change the speed like this. By changing the parameters like poles and speed of the generator, we can change the frequency. We can change the frequency and also we can change the voltage also. It also depends upon the speed. And maximum power point tracking. So this maximum power point tracking MPPT ensures the optimal power extraction from the wind. So it is possible only by adjusting the generator's speed and pitch angle. And doubly fed generator are typically wound with 2 to 3 times the number of tons of stator. This means that the rotor voltages will be higher and currents respectively lower. So typically plus or minus 30% of operational speed ranges around the synchronous speed will be possible, and the rated current and of the converters also lower, and which leads to a lower cost in the converter. And the drawback is the controlled operation outside the operational speed range is impossible because of higher than the rated voltage, rotor voltage. So the voltage transients due to grid disturbances. So here disturbances means there may be a voltage rise or voltage drop, swell or sag, and these are also called dips, voltage dips. So 3 and 2 phase voltage dips in case of voltage transients will also be increased. So in order to prevent these rotor high voltages and high currents resulting from voltages from destroying the insulated gate bipolar transistor in converters, insulated gate bipolar transistors, and also diodes of the converter. So protection is required. Here in this DFIG, a protection circuit called crowbar is used here. So it's a mathematical model. So this mathematical model is used to simulate and optimize the generator performance here. So the DFIG model is usually represented in the form of differential equations and also DQ reference frame. The dynamic model can be designed as a compact set of equations and can be simulated by a digital system like computer-based hardware. In DQ model, it simplifies its analysis by transforming the three-phase stator and rotor variables into a two-axis. One is D-axis and it is Q-axis, direct and quarters axis. This enables easier control and simulation. So it is DFIG is nothing but a wind turbine generator where the rotor windings are connected to the grid via power converters. Finally, this allows the variable speed of operation. So here in the DQ modeling, the advantage is it transforms the three-phase variables like voltage, current, and frequency into a rotating frame of reference, which are helpful in simplifying the equations and making the analysis very easy. So advantages of DQ modeler. Here simplified equations, set of simplified equations are easy to manipulate and solve, especially in case of dynamic analysis. And independent control is possible here. Here, direct and quadrature components can be controlled independently here. Simulation. So here MATLAB or simulating software are used to simulate the DQ model very easy. Applications are, this DQ model is widely used for analysis and control and simulation of DFIG based wind turbines. Advantages of this DFIG. So efficient power extraction over a wide speed ranges in wind turbines. Ability to active and reactive power independently control. We can control active and reactive power. So it reduces the converter size. So grid stability is improved and cost effective for large wind farms. There are some limitations also. So requires sophisticated algorithm for the controlling system. So here brushes and slip rings are required, are required maintenance. So vulnerable to grid disturbances without a proper protection mechanism. So comparing to traditional generator, DFIG causes higher initial cost and possible overfitting converters load. Applications that are widely used for power plants like grid connected renewable energy generation and suitable for variable speed wind turbine, utilized in small hydro and other renewable energy systems, integrated into hydro RES for energy management, provides services like voltage regulation, reactive power control, compensation, and frequency support. So protection system is required to DFIG system are over current protection, voltage protection, rotor protection, and grid fault protection. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.